Dear students, we have discussed about the radius, atomic radius and ionic radius of p block elements. You can see these p block elements in the periodic table which is in front of you. See the radius of boron, it is 0.82. You remember the atomic number every time and electronic configuration. You have to compare these properties with respect to the atomic numbers and electronic configuration and the position of the particular element in the periodic table. Boron, which is present in third A, having the 0.82 radius, 1s2, 2s2, 2p1, that is 5. Boron atomic number is 5. Carbon atomic number 6, 1s2, 2s2, 2p2. Means what is going on? In case of boron it is 2p1 and in case of carbon it is 2p2. Means p orbit having 1 electron in boron and carbon having 2 electrons. Nitrogen is 1s2, 2s2, 2p3. It means that nitrogen have 3 electron in p orbit. Concentrate on the electronic configuration. Boron have 1 electron in its orbit, that is in its outermost orbit. Carbon having 2 and nitrogen have 3 electrons. Atomic number 5, 6, 7. See the radius, it is 0.82, 0.77, 0.75. Continuously decreasing. The trend is continuously it is decreasing because the increasing nuclear charge. One by one electron is entering into the orbit, and that too in the same orbit. Electrons are entering into the orbit in the same orbit. It means that there is nuclear charge is increasing, which pulls the electron inside and decrease the radius. When we are talking about the oxygen, it is 1s2, 2s2, 2p4. Atomic number is 8. So the electron is now the radius is 0.73. In case of fluorine, 1s2, 2s2, 2p5 means P1, P2, P3, P4, P5. It means that total number of electrons are increasing in p orbit. It means that there is increase in the nuclear charge which pulls the electron inside and decreases the size, decreases the radius. But when we are talking about the top to bottom, when we are moving down the group, boron have 0.82, aluminium have 1.18. You can see that period number 2 means smaller size. The size of the shell is smaller, that is it is equal to 2. Then the size increases. The shell, new shell, there is the new shell, there is extra shell, and it is so large that it's outweighed the effect of the increased nuclear charge will minimize there. It means that boron have a lower radius than the aluminium, than the gallium, that is 1.26, indium 1.44 and 1.48. Students, you must remember one thing, that radius decrease from left to right and increase from top to bottom. This is all about the discussion of the atomic radius. Now I am going to discuss about the ionization energy. What is the definition of ionization energy? The amount of energy required to remove the outermost electron. Ionization energy is the amount of energy required to remove the outermost electron. See, in case of p block elements, what is the position here? Before going to the ionization energy, again you have to concentrate from left to right, that is in a period, and then again down the group. The ionization energy of p block element increases along a period. Amount of energy of the p block element increases along a period on moving from left to right. Why ionization energy increases? In case of boron, only one electron is there, that is 2p1. Only one electron is there. If you will remove that electron, it will get extra stability. In case of carbon, it is 2p2. Now you have to remember, you have to remove this 2 electrons, or there is the possibility of more energy is required to remove the electrons. The ionization energy increases from left to right and decreases on moving down the group. Top to bottom, the ionization energy decreases. Why? Because there is the entry of extra shell, and the effect of nucleus to that outer shell will be less. The first ionization energy of the element group 13 exhibits exceptional behavior. The ionization energy of the elements of this the ionization energy of element of this group have been found to be lower than group 2. The reason for this exceptional behavior is that loosely bound p electron is to be removed to produce M plus in case of group 13 is more easy, whereas more strongly bounded s electron of the same energy to be removed to produce M plus in case of group second A, it is more hard. Therefore, it is difficult to remove the electron from the S subshell than the P, D and F. This is all about the ionic radius. Remember only one thing, that total the ionization energy increases from left to right and decreases from top to bottom. Now, what do you understand by the word electron affinity? We will stop here for the next.